friends. Welcome to my YouTube channel, Dr. J Official. I'm Dr. Jamali, psychiatrist working in the UK. And today I want to talk about data analysis. Let's talk about the p-value and the confidence interval, because you will see that in many articles, most of the articles, where you will see the p-value and the confidence interval. How do you read the p-value and the CI? So firstly, in order for the particular study to be statistically significant, the p-value has to be less than 0.05. Okay. Now that in itself is not enough, because most of the time when you do a critical appraisal or critical review of an article, when you see the p-value less than 0.05 and that's it, nothing else is mentioned, then there is something wrong, because p-value in itself is not enough. What you need along with it is the 95% confidence interval. This could be 95% or 99%, but 95% at least, 95% of confidence interval. Now, when you're doing a critical review, don't worry about what the p-value is, what the confidence interval is. What you need to know is whether this data is statistically significant or not. And this is what you need to see, the p-value and the confidence interval. It has to be both, not just one. Now, once the p-value is less than 0.05, now you need to check the confidence interval. When you are reading or looking into the confidence interval, value of no effect is very important. Now, value of no effect is considered to be 0 if the data is measuring the absolute risk reduction, or the number needed to treat, NNT, right? So if the data is measuring these three indicators, then the value of no effect is 0. However, if it is measuring the relative risk, odds ratio, or standardized incident ratio, then the value of no effect is 1, right? So when it comes to ratio, the value of no effect is 1. Okay. Now, why this is important? Because this is how you determine whether the confidence interval is statistically significant or not. Now, let's take an example. Say you're reading an article and it's mentioned that 95% confidence interval for a relative risk is 0.5 and 1.2. So it will be in bracket 0.5, between 0.5 and 1.2, the confidence interval. So we know that in relative risk, the value of no effect is 1. Now, what does that mean? If the interval here, if 1 is between this, then it is statistically insignificant. Okay, so if we are measuring, if the article measures relative risk, we know that the value of no effect is 1. Now here in the article it is 0.5 and 1.2, and you can clearly see that there is a 1 between this. So if there is a 1 between this, which means that the data is statistically not significant. Now let's take another example. 95% confidence interval for an absolute risk is 0.5 and 1.2. Okay. Now for absolute risk, the value of no effect is 0. Okay. Now let's have a look. Does 0 lie between 0.5 and 1.2 in absolute risk? No. 0.5, 0.6, 0.7, 0.8, 9, and then 1 and 1.1 and 1.2. There is no 0 there. So now, because 0 is not between the confidence interval measured, which means that this data is statistically significant. Does that make sense? Is it clear now? So when you're reading the p-value and the confidence interval, first the p-value, then the 95% confidence interval, then you need to know the value of no effect, and then you see the number which is the which you will see in the confidence interval, and then you see where is the value of no effect, and that is how you determine whether this data is statistically significant or not. However, I've talked a lot about statistical significance, but statistical significance does not mean clinical significance, right? Now, why is it that I'm telling that statistical significance does not mean that it is clinically significant as well? What if the condition you are trying to identify the risk factor of, for example, is rare? What that means is, if it is rare, the sample size will not be, big enough. So you will get a very small sample size. So there could be a possibility where, with a smaller sample size, the data is not normally distributed. If it is not normally distributed, you're using a non-parametrics, test, where you may potentially not get a statistically significant data. However, then it's not only about the p-value and the confidence interval. You look into it and you see what was the sample size. They will give you more data on the risk factor. What were the confounding variables? What was the duration of the between the onset of the between the risk factor and the onset of the disease. So there are a lot of factors you include. The other thing you need to include is that, say, if you're reading a meta-analysis, or if you're reading a systematic review, how many studies have they included? Have they included only studies with the larger sample size? Why is it that they didn't include studies with the smaller sample size? Because they knew that it will not be statistically significant. However, a study with a smaller sample size may be significant. So sometimes that is not included, and that is where bias comes in. Whether it is information bias, whether it is selection bias, that's where you're very selective in which studies to include and what not to include. So again, it is not only about statistical significance. Statistical significance does not mean clinical significance. And I mentioned about the normal distribution, the parametric, non-parametric. We will talk about it in my future videos. Okay, but for today, when you are doing a critical appraisal or a critical review, you look into the p-value, you look into the confidence interval, and that is how you interpret the confidence interval. Now, this is meta-analysis. Okay, now this is a forest plot. This is just a sample, but like when you see a journal article or systematic review, there are a lot more numbers here and charts and all, but I'm keeping it simple here. Now, if you see here in forest plot, what they do is they compile all the studies they've included, and then they put it in a plot which is called forest plot. And this is what you see. What they have done is they have, say in this forest plot, they've included all the studies where relative risk was measured. And now we need to see whether this particular work is statistically significant or not. Say they've included these 4 studies. What is it that you need to look in this forest plot to arrive at a particular conclusion? Relative risk. So as mentioned in the previous slide, relative risk, the value of no effect is 1. Okay, so that is something you need to keep in mind. Value of no effect for relative risk is 1, and that is what you can see here. This is the value of no effect. Now you're seeing this line with a square in the middle everywhere. If the line is crossing the value of no effect, which means that that particular study, the data in that study is statistically insignificant. because the line has crossed the value of no effect. But if you look at the other studies, it has not. So there are two studies where the relative risk was lower and one where the relative risk was high. Okay, so that is what it shows here. The other thing you need to be mindful of is the square. So bigger the square, which means bigger the sample size. The sample size was more, that's why it is bigger. So here you can see on the left where the relative risk is lower, there is one study with a big sample size because there is a bigger square, and there is one study with a relatively smaller sample size. In the risk factor, where it shows there is a higher risk, you can see the sample size here. It is smaller. It is, you can see, say it is similar to the one here, but there is one study on the left where they had a bigger sample size. So that is something which is significant. Now, the other aspect to look into is this diamond shape. What this shows is wherever the diamond shape is, whether it is left or the right, which shows that most of the studies fall into this side. And that is where this diamond shape is. So most of the studies done for this particular work shows that the relative risk in most of the studies was lower. And that is where the diamond shape is. Sometimes the diamond shape may be crossing this line. Then you can interpret in a way that this diamond shape, it was because it is crossing the line, or it is, say, just like this. Half of the diamond shape is on the left and half on the right, which means that the studies done does not arrive at a proper conclusion, at a clear conclusion. So it may be the data is not significant enough. But again, I'm saying it is all about data here. We don't know whether this could potentially be clinically significant or not. But this is how you read a forest plot, right? So one is, if the line is crossing the value of no effect, which means that in this study, the data was statistically insignificant. Bigger the bigger the square, bigger the sample size. And if the diamond shape is either on the left or the right, which means that that particular, wherever it falls onto, it means that whether the risk is high or low is statistically significant. In this case, the relative risk being low and the diamond is on the left side, which means most of the studies suggest that the relative risk is low. Okay. So these are the common things you look into the forest plot. However, I mentioned earlier that statistical significance doesn't mean that it is clinically significant. And that is where, the funnel plot comes into the picture. If you look at the funnel plot, treatment size effect here, what that means is towards the end of the funnel, you will see studies with a larger sample size. So that's large studies. When you move towards the upper end of the funnel, which is broader, there you will see the smaller studies. Now that is where you try to identify whether there has been any potential bias. Because as I mentioned previously, that sometimes, there could be a possibility where even if the data is not statistically significant, but there may be some clinical relevance or significance to it. Why? Because there could be a possibility where they've not included smaller studies. And how do you arrive at it? You do a funnel plot. Sometimes when in some of the funnel plots, they would include larger studies, but there wouldn't be much of smaller studies there. Or sometimes it would be an outlier, which means that they've not included smaller studies here. They've only included studies maybe with statistical significance. And most of the time, the larger studies would be towards the narrow end of the funnel and the smaller studies towards the broader end of the funnel. So again, when you read the funnel plot, you need to see that whether they've included smaller studies or not. If they've not, maybe it would be somewhere in the outliers here. And that is something which you need to pick on, that, pick up on that. Yes, in my critical review, I noticed that they didn't include some of the smaller studies which could potentially be clinically significant. And we've talked about the p-value. We've talked about the p-value, the confidence interval. We talked about the forest plot, and then the funnel plot, and the importance of reading the data, and to determine whether this particular data is statistically significant or not, and then whether this data is eventually clinically significant or not, because that is what we all aim for. That whether this data or whatever we are reading is actually clinically relevant or not, because at the end of the day, that is what matters. So I hope this was useful. Please feel free to add your comments, feedback, questions on the chat box, on the comment box. Uh, I would be more than happy to address those. And if you feel that this video was useful, please do share and subscribe to my channel. And I'll see you in my future videos. Take care. Bye bye.